So my first story is about the interstellar asteroid Oumuamua, and this was discovered actually less than a couple years ago, in I think January of 2017, and and now we'll talk about the discovery in just a second. But Oumuamua is actually a Hawaiian word and it means like a soldier or an explorer or a scout that's sent in to sort of discover the enemy's position. And this is actually very interesting because Hawaii is a location where we actually have lots of telescopes. And actually, in recent years, there has been some conflict between native Hawaiians and astronomers who want to put more telescopes, especially the 30-meter telescope up on Mauna Kea. But there has been native Hawaiians who are interested in astronomy, and so the naming of Oumuamua sort of took advantage of a process that was put in place that allowed native Hawaiians to give names to asteroids and other objects that were discovered in Hawaii. And recently at the American Astronomical Society meeting, Greg Laughlin, one of the astronomers who discovered Oumuamua, told a story about how, there aren't many Hawaiian words that are in English dictionaries. So when he was texting people, his phone kept wanting to spell correct Oumuamua to something else. And so, he had to keep correcting his phone until finally the phone learned that Oumuamua is an actual word that he wanted to use. And of course, what then happened was that Oumuamua started appearing everywhere in his text, even in places that he didn't want to. And so here is a tweet that someone sent during his talk, quoting Greg: "I had the honor of asking the plumber who came to fix her clogged drain if he could Oumuamua." So Oumuamua was discovered at the Pan-STARRS telescope in Hawaii. It's actually not on Mauna Kea. It's on another mountain. But what Pan-STARRS does is it surveys the sky looking for changes, basically looking for asteroids, and potentially near-Earth asteroids that could, far in the future, be on a collision course with planet Earth. And here is the camera for Pan-STARRS. It's 1.4 gigapixels, or a billion pixels on the camera. It surveys a good chunk of the sky. And what it found in early 2017 was an object that had what is known as a hyperbolic orbit. And this means the orbit originates not somewhere in the solar system, but originates from outside the solar system. So comets and asteroids that are in orbit around the sun have elliptical or perhaps parabolic orbits, but this type of orbit definitely says that it's coming from well outside our solar system. And one of the things that astronomers did was to measure what's known as the light curve, meaning how the object varies in brightness over time. And so what they find is here is a plot of time, and then these are various observatories. So they're looking at it with the Gemini Observatory, the Very Large Telescope, the Keck Telescope, observatories in both the northern and southern hemispheres. And it had this very strange variation in the light curve, or variation in the brightness. And what the interpretation is that it's rotating, but it's rotating roughly about once every 8 hours, but it has basically a cigar shape. And so as when you see the full length of the cigar, it's very bright, but when you see the very end of the cigar, it's not showing as much of an area to us, and so it appears 10 times darker, or 1/10 as bright. So that's a huge change in brightness, but we attribute that to the fact that it's elongated. All right, another really interesting thing about Oumuamua is that its orbit appears to have changed slightly in its trajectory as it's leaving the sun. And so the interpretation there is that the object is actually outgassing. And so after its near passage to the sun, the warmth and heat from the sun has heated up the ices on the surface of the asteroid. And as it evaporates, as the ices evaporate, the gas gives a little push to Oumuamua. And so Greg Laughlin, the astronomer who I mentioned at the beginning, he has a paper coming out where they show that the outgassing from a cigar-shaped object can actually lead to the type of behavior that we see that we saw in that video. Whoops. So there's been a lot of interest in Oumuamua. In March of last year, 2018, there was a paper that came out where, based on the statistics of pan-stars discovering one interstellar asteroid during the time that it's been running, the authors of this paper then estimate how many objects like Oumuamua must be out there. And what they find is in this quote, they expect a mean density of 0.2 objects per cubic astronomical unit, or over 20 trillion objects per cubic parsec. And what that means is there are roughly about 60 trillion Oumuamua-like objects per cubic light year out in interstellar space. So that's a huge number of potential objects that are out there, given our current sample of one. Of course, things could change once we have better statistics, but if we discover more of these, that will likely bump up this number. So the paper I want to talk about is something that has just been recently submitted, so it hasn't been accepted by the journal yet. But what they were looking at is, based on these sort of statistics, how likely is it for these interstellar asteroids to actually still be in our solar system? So they start with, they point out some basic statistics, like the fact that we expect to see roughly 60 trillion of these types of objects per cubic light year out in space. We expect, because of the gravity of the sun or Jupiter, the largest planet in our solar system, they could easily capture one of these every 80 years or so. So once, approximately once a century, and there could at any given time be up to 6,000 captured interstellar asteroids in our solar system. So the next question for this paper is, how many of these could we expect to actually see or observe? And what they did is they ran a computer simulation of 100,000 potential objects, and by working out the orbits of these potential objects, or that could potentially be captured by within our solar system, they find that out of that 100,000, about 3,000 actually get captured in the computer simulation. And this plot just shows some of the orbital characteristics of those captured objects. But what they also find interesting is that there are actually objects in our solar system known as the Centaur asteroids. And these are asteroids that orbit out, not in the asteroid belt, which is between Mars and Jupiter, but they orbit out amongst the large giant planets. So out between Jupiter, Saturn, Uranus, and Neptune. And so by perusing through the catalog of known Centaur objects, they find there is 2, 4, 6, 8 objects that have orbital criteria that are similar to what's expected from their simulations. And then finally, they talk about what future telescopes might be able to observe. And so there's a telescope that's currently being built, the Large Synoptic Survey Telescope, or LSST. And when it goes online in next year, and then when it actually starts taking real science data in 2022, it's going to scan and map the sky every 30 seconds. Or it's going to take an image of the sky every 30 seconds, but over the course of a night, it'll have mapped the entire sky. And this gives you a sense of how big each of these images is. So this is the size of the full moon. The camera has over 3 billion pixels, so it's much, much larger than pan-stars. And the authors of this paper expect that, depending on this graph, just shows the cumulative number of objects that are discovered based on how far away they are. So the Earth is at 1 astronomical unit. 5 astronomical units is basically where Jupiter is. 10 is roughly where Saturn is. And so if, based on their modeling, they would expect to see hundreds of Oumuamua-like objects discovered by LSST. So what's really interesting about this is that people talk about how difficult it would be to send an interstellar probe to visit other star systems, other solar systems around other stars, to try and understand the conditions there. But here is a possibility where if we can identify these interstellar asteroids that get trapped in our solar system, there's a possibility for us to go out and explore other solar systems just by staying home, or at least staying within our solar system.